Okay, welcome to system design session of IT Society. We will handle together today video recommendation system design, aka YouTube recommendation engine design. So here is the outline I want to follow today. I will give the problem statement. You can see this question in different ways. In different interviews, and there will be a back of the envelope calculation, because whenever there is a streaming application, a recommendation engine, which means big data, streaming, which means throughput, lots of network throughput. These kind of things needs a calculation, but I want to do this calculation at the end of the session if time allows. If time doesn't allow, you can just jump into this page yourself after the session and you can see the calculation, an example calculation. And then we will jump in also system and ML design. Inside the system and ML design, I'm putting this into two different tracks. One is the overall system design, which is a design of an application like software, like regular backend software engineering interviews. And then machine learning design. I'm just disclaimer, I am not a machine learning expert. So machine learning engineers, I know here there are some with us. Please jump in and give your contributions. After machine learning design, I will also talk about a bias, which is making these kind of recommender engines working incorrect, this position bias. And we will talk about the solutions for position bias. And also, I want to discuss today Lambda architecture. Most of you probably didn't hear about that. I just heard it when I was preparing for the interviews for the big tech companies. One of my mock interviewers told me, like, you explained very well, but like the concept is called Lambda architecture. If you also call the concept in the interview, this will also be nice, and go and read this concept too. I will also give you some nice resources about the concept that you can do a further reading. We will also give some resources for recommendation algorithms used in those kind of systems. And I have some references for you. So first of all, problem statement. By the way, are you able to see my screen? How is the size? Okay, I saw some thumbs ups. Okay, I'm also looking at monitoring the chat window. So if you have any questions or comments, raise your hand, put something in chat. I'm checking regularly. So problem statement. We are trying to design a video recommendation system like recommended videos list on YouTube. So this is something like that. I just clicked on relaxing jazz Pioneer Radio video of YouTube, and it is just recommending me some related videos. It's not related to only that video, but it is also related to the history that I have clicked in the past for some time, actually. I don't know the real time amount that they are checking, actually. So it is recommending based on my user attributes plus my history plus the relations between these videos that YouTube already discovered. So you can see the same problem in different ways, like recommended products on Amazon. When you log in your Amazon account and when you just like look your homepage, you see some recommended products Amazon wants to sell you. recommended courses in Udemy based on the courses that you have enrolled and also followed, actually. So some courses you purchase, but you don't follow or you don't complete. So Udemy is also considering this. Recommended songs on Spotify based on genre, your history, the artists that you follow, etc., etc. So you can see this in different ways, different variations. I suggest you to, after this session, you can just take one of these, Spotify or Udemy or Amazon. You can just do the system design yourself. Try to do the system design yourself. So for the overall system design, as I said, I am just skipping this section for now. I want to move on the overall system design. So the overall design is actually, this design is very lean, very clean. We can add more, way much more services and layers to that. Also, you can see I'm not capturing really the model training side of things. I will handle this in the ML system design later. Right now, we are just interested in serving side of things. When a user clicks a link of YouTube, opens a link of YouTube like this, and requests a video. So when I request this URL, I want to watch this video, right? But YouTube doesn't give me only this video, but also gives more, actually, like these metadata related to video plus recommendations after this video. So to do this kind of a thing, like when you call this URL, you are calling through a load balancer, which is the regular networking device that we put in all system design almost. We have lots of application services here. So the application service will prepare the response to me and will give it back to me. So the steps are user clicks. Ibrahim cannot hear anything. The others can hear me, right? Okay.
Yes.
Okay, so probably for him. Okay, so so when you click on a URL, application service is responsible of creating the response, mixing up all this, the video URL plus the recommendations plus the metadata of this video, etc., and give back to you as a web page. So when you click, application service is kicked. So app server then doing simultaneously different works. Fetches the CDN URL of the clicked video from the database to serve in the rendered page for streaming. It is not actually done this way. I know there's a way much more complicated system behind, but this is a very naive way of doing this. So the application service is not streaming, but it is just fetching the video URL and giving back to user. But while fetching the URL, it is giving to YouTube client something else. So it fetches candidates from candidate generation service and sends candidates to ranking service. What does candidate mean here? So for recommendations, it is very hard to, let's say YouTube has 100 billion videos and we want to recommend 100 out of them. So it is very hard to compute 100 out of 100 billion in real time in the request response time and serve it to user. So first of all, you do some very naive filtering and you create some candidates out of 100 billion with some filtering. very, very naive way. Let's say the title match or the tags of video match, etc. So it fetches the candidates from candidate generation service, which means like, let's say you have 1,000 candidates coming out of 100 billion with a very fast, very, very fast query. Then these 1,000 candidates are sent to ranking service. So application service is calling candidate generation service. Candidate generation service is doing some candidate generation based on some models, etc. And SQL queries actually, very basically, on video metadata and creates a 1,000 list and get back to application service. And then application service asks this question to ranking service. Hey, ranking service, can you rank this 1,000 YouTube recommendations for me, for this user? Can you do this? So that ranking service is asking to 3 different data stores. One is the video metadata. So for this 1,000, it needs to fetch some relevant information like duration, like the artist or the channel that video is on, or the tags of the video so that it will use in ML ranking. Also, it fetches the machine learning model from ML ranking repository. This doesn't have to be a SQL or NoSQL database, by the way. These red ones are data stores. It can be a database relational, it can be a database non-relational, or it can be an S3 or a blob storage like that. So most of the time, we store ML models on S3, for example, or like blob storages. We cache on the ranking service, by the way. So we just like fetch also the ML model for ranking. Also, we need, so I'm ranking these videos, this 1,000. I will do the ranking based on the video metadata, but also I need the user, because like when I ask this question to server versus Ahmed asks this question to server, our recommendations are different personally. So personally here means I need also some user data. I got this user data to the ranking service also, and then ranking service is now doing a machine learning model ranking actually. But this is also a fast computation because it is ranking only 1,000.
Erdem?
Yeah.
Can I add something?
Sure.
Ranking service. Yeah. We can classify the features. Actually, we are using features, model features, and let's say dynamic features and static features. So the user data, video metadata, those kinds of features can be classified as dynamic features, and it can be changed and depends on the request, right? And the video request and the client request, and also some static features. And we can keep those features in cache like Redis. It is since otherwise, you know, the cost will be higher. So we should have a cache and keep some static features there. And also, as you mentioned, we can have multiple machine learning models and in different, you know, machine learning frameworks. And I can give some examples like EBM, TensorFlow, PyTorch, different kinds of machine learning models, and we can keep in S3, something like that. And also, I can give an example from Amazon SageMaker. And we can use SageMaker. So our machine learning model can be executed on SageMaker, for example. Most probably there are some different platforms on Microsoft Azure or the other Google Cloud. But for AWS, yeah, we need a kind of platform to run machine learning models. So ranking service encapsulate all this, and just rank the video IDs.
Mm-hmm. So
Yes.
did I understand correct? This
Yes.
is the cache for some static features for videos, right?
Yeah, for example, there are some specific videos, right? Action movies. For all action movies, we can use some static features as well.
Okay.
For different kinds of videos, right? We need those data, and we need to use from also some default, as you mentioned, training, right? When you use, multiple times, then we can use some default values as well. For example, some some dynamic features cannot be available, right? Maybe. And then we need some default values. Also, we can keep those default values in cache. So provide a model. Otherwise, model needs that data as well. So we can also when we run multiple times, our default values can be updated. So we don't need to change anything. Just of course, there should be a pipeline. I don't know. Maybe you will talk about pipeline. For example, that cache must be fed by a pipeline, data pipeline.
Yeah. Thank you for your contribution here on that side. Like this system design right now is not showing the model training or the feedback loop of this. Only this is only serving, but this is a good contribution. Definitely, we need some caching on some layer here, like not all like for ML ranking repository. Also, we can use some cache on the ranking service side, because this is kind of not very frequently updated kind of machine learning model.
Yeah.
Thank you. Any other contribution from others? Okay. So another thing. Oh, Fatih is saying, I also think there can be pre-computed recommendations per video, independent from user, and recommendations per user, independent from video. And candidates are not fully generated in real time. Oh, this is a good idea too. Might be, yes, might be. We will talk about fast and slow pipeline, Lambda architecture. What you are saying here, Fatih, is reminding me this concept. We will touch base, and I will remember your comment there actually. Thanks. So there is also these are about the generation of the response to be sent to the user, but also the interaction of the user with this page is also creating some engagement and satisfaction attributes in databases. So when you start watching a video, and when you complete watching a video, maybe when you pass, like when you watch the first 20 seconds of the video, it means you're engaged, you are watching this video, you're not just like looking at the first few seconds. So these kind of the user activities are also logged on an engagement service and satisfaction service. When you give a thumbs up, when you like something or dislike something, or when you share something with some of your friends, or when you save, these are all kind of engagement or satisfaction related attributes. So if you are talking about a recommender system in a system design interview, I highly recommend you to create engagement and satisfaction services. It doesn't have to go through the same single application service, by the way. It's not a very good design. As I said, I didn't spend too much time today to create the system design. This is not a very, very good design. You should do better in an interview. It's just like to give you the concept of serving layer of a recommendation system. So engagement service is writing data to engagement tracker DB, satisfaction service to the satisfaction DB. So I can say easily that like engagement tracker and satisfaction DB, they both are aware of users and videos. So this user engaged to this video, or this user liked this video or not, kind of details on these databases. And these are also used to train our machine learning model. Yeah, so fourth step, ranking service ranks the candidates using, as I said, ranking service is using candidate list that I passed, ranking ML models that it reads from ML repository, video metadata, because to do ranking, we also need some video information, and user data, because we need some user information. As Ismail told, for some static features or very common features for some high-level groups or something, we can just read very fast from the cache some of these information. And engagement service puts stream-related events, as I said, to this DB, and satisfaction-related events, likes, dislikes, to satisfaction DB. So this is kind of like high level of the serving side of things. I also want to talk about machine learning design. As I said, I am not a machine learning engineer. We have machine learning engineers here, so please contribute. But these are some valuable resources that I was able to find when I checking this topic in the internet today. The first one is, this is very famous actually, 2019. And this is very understandable kind of an article. I really suggest you to check this. This is from Google, 2019, recommending what video to watch next. Absolutely our problem today. And multitask ranking system. So this is their system. You can see all the details of these layers in this article. It's not a very hard to read kind of article, not very mathematical, actually. You can understand easily. And also, this is also talking about the selection bias that I will talk later today. So as I said, there are two main steps in recommender engines. This is kind of like, I'm giving some like useful information for interviews. So there are two main steps. One, candidate generation. Why we need to do a candidate generation? Because it is too costly to run a ranking model across billions of videos for each and every YouTube user. Look at this, for each and every YouTube user. If you do this for 1 time a day, 10 times a day, 1,000 times a day for a company like Google, that is fine. But even for a company like Google, it is not fine to rank billions, hundreds of billions of videos, actually, real time. It is not, maybe it is possible, but it's not feasible. So billions of videos are queried simply by different aspects, and a few hundred per each query are selected as candidates. Look at this. We are doing a union of different query results. Each query is giving, let's say, 100 results. And these are very simple queries, very fast queries from a very optimized data stores. We are fetching these queries. For example, by matching topics of query video. So we know which topics this user is interested in. We can do a kind of a similarity to the other videos also. based on how often video has been watched together with the query video, kind of like an data mining a priori algorithm, like market basket analysis, which product is purchased with another product in the supermarket, kind of like analysis we can do. We can do the same thing for videos, like the users who watch this video also watch that video, kind of relationships can easily become pre-computed somewhere. And by matching tags in a similarity vector, the tags that user frequently watches and the tags, the videos that we have. So we can just like each of these queries and some others, maybe 5-10 different queries, each of them can bring us 100, let's say, results. We just like union all these results. Let's say we have 1,000, and then we ask the question to ML ranking them. So given currently watched video plus context, what does context mean here? This is user data. So currently watched video plus context, we know the user also. Not only like, don't think about the user data in a very naive way. It's not only the age or gender of the user, it's also what time this user is watching that video. In which time zone right now is she, or what is her mood today? Like even lots of things actually, if you are able to get. And then also 500 or 1,000 candidates fed into this ML ranking. So our purpose here, rank those candidates and recommend them to the user based on the following objectives: engagement objectives, clicks, etc., and satisfaction objectives, liking or rating the video. So we collect these information all the time for that user. We know this user in terms of users' engagement and user satisfaction, and then we rank this 500 or 1,000 videos based on users' pre-stored engagement and satisfaction. Yalchin has a message here. When the first time user signed up, what should we recommend? We don't have much information of user. I don't know like the exact answer of this, but I just like, even at that time, we have lots of information like from which IP address this user is coming from Silicon Valley, then this user might be a software engineer or something, or some browser cookies or some, some information that we have already stored. Any ideas, Yalchin, Smile?
Erdem, yeah, I think I mentioned maybe against stressed, there are some default values. If some missing data occurs, then we use default values. How can we extract that default values? We run multiple times, right? So in ML models, eventually you provide just some values between 0 and 1. Those are just values, right? So you have some default values. If some missing data, you just provide default values. Yeah, this is, and you can extract that data from the cache.
Okay.
So in this case, system is recommending the list based on all that default values. And maybe, yeah, in that state also we will have some information like maybe, yeah, user's location and then, yeah, some other information.
Yeah, that's why I thought like for default values for this kind of thing, Google is collecting already lots of info from us.
Maybe popular videos currently.
Yeah. Current popular videos, absolutely. I believe ML ranking model is also, while ranking all, it is also putting some popular. There can be some boost score for populars or something.
Actually, in this kind of structures, people are using generally collaborative filtering when they are going to, for example, the if there is no data about the user, with respect to the location part or maybe the different kind of stuff that you can use, but generally people are using the collaborator filtering, which means that wherever the people are living in this area or in the state, whatever, and then they just use that the recommendation coming from this kind of users leads or like something like that. So the collaboration filtering is very popular for this kind of recommendations. They can use this. Also, like the Amazon or the Netflix, also this kind of methodologies using the same thing to recommend to the user what kind of from the background. There's a different kind of filtering, but the collaboration filtering is generally based on with respect to the area that the people are living there. So in this kind of machine learning algorithms are always recommend some kind of stuff to the user. So never give us some kind of default values. Generally, they give us some kind of recommendation for all the users that they have, whether there's some kind of data or not.
Default values means providing to the machine learning model. You know, the model needs some static features, say dynamic features, right? And if some missing dynamic features, you know, happen, then just provide the default values to that features as a value. Then the machine learning model again is run and provide some rank, of course.
Okay, so we are not talking about the training side of things. Model is already trained. We are talking about the calculation and using of this model side, right?
I'm just
want to
execution.
Yeah, the execution side, the serving side of things. Then in the serving side, some features are required features, and if there is a required feature missing, as Ismail told, so there are some default values that we can do some imputations on that side, or as Ur told, I remember using collaborative filtering to compute some required fields out of the other information that we have, and use that way, which may cause a bias. But these are very, very detailed and kind of edge cases in this for this interview, kind of. Cool. One thing that I want to ask you here. This is from one of the resources that I have seen today. So for this problem, the scale calculation by the author was like that. I just wanted to ask you, do you think this is an accurate calculation? Is this correct? Or do you have any objections? So 2 billion monthly active users, from 2 billion monthly active users to per second user calculation is like this. Do you think is this correct?
It seems reasonable to me for this design.
Erdem, I think you need to divide 60, not 600. Since you already say hour. It's okay, minute and second. Okay.
No, I think mathematically it's not a problem. But my point is here is 2 billion monthly active users. What does monthly active user mean? Like 2 billion people in the planet get into YouTube website, right? In the last 30 days, in the last month. So
generally in the interviews, people are give us some kind of assumption. For example, 2 million monthly subscription, but they can say that okay, assume that 2 billion about people are subscribed, but only 20% or 30% is going to be daily use or something like that. So with respect to some assumption, you are going, because 2 billion is also going to be like every day they are going to also continue videos, right? So there should be some kind of assumption here, then you continue to the calculations actually.
Very good catch. So 2 billion naively divide to 30, it is not a good calculation, I believe, because people are using YouTube every day. So this is 2 billion monthly. I would say maybe 500 million daily, because like every 4 days, probably user is looking at getting into YouTube and checking a video actually. So maybe 2 billion to 2 billion. The daily is also 2 billion. And am I clear what I'm trying to explain?
Yeah, you're right, but it depends, right? So if that will be an API call, you're right. So how many calls depends on how long it is active on the servers. But if it is something like a pipeline and offline process, and we are only calculating once in a month for an active user, and keeping this somewhere in the cache and using that, reusing the same data again and again, that might make sense. But yeah, as you said,
this is monthly active user. I just wanted to give your attention on that side in the interviews. Just be careful while extracting hourly active user from, let's say, monthly active user. Dividing naively is not a good way. I would just like ask the interviewer, what is the hourly active user of YouTube? Then from hourly to minute by minute active user, dividing to 60. It is reasonable. It is not that kind of like big mistake. But from monthly getting into second per second user, active user, it doesn't seem reasonable to me. It should be way much more than 700. But still, this is very big. The gist of this calculation is like we need a very scalable system, actually. So for training model, there are 2 phases. There are two things that for model, very important. Which recommended videos the user clicked. By the way, we have 10 more minutes. I will go a little bit faster. Which recommended videos the user clicked? The user liked the video. These are the classification problems of each engagement and satisfaction. For engagement, classification problem is click or not. So if I show this user this video, will this user click on this video or not? Kind of binary classification problem here. Or for satisfaction, classification problem is, will this user like this video or dislike this video? So this training model has another problem, which is regression problem. For regression, so for engagement and regression problem is watch time after click. So yes, it clicked, the user clicked, but like how long this user will watch this video. This is the regression problem. And for satisfaction, if there's a scale of like, what will like, will it be out of 5, let's say 3 or 4 or 5 for this user? You need to predict this actually with a regression model. So your machine learning models can be in 4 different dimensions for this problem. ML ranking design here is this. I won't go the details of the sigmoids and this inner layers. I just want to just get your attention to here. So while we are serving the recommendations to user, we have 2 things that we collect. The candidate video features, like the candidates that we calculated, and the user features and the context features. Context is just like geolocation of the user, the time zone, etc., and the user-related user attributes. They all involve in, and we just like do a calculation in different layers. I won't get into the details of this. We don't have time. You can just like check this which part? Yeah, this ranking and afterwards the model architecture. You can just check this part of the Google's article, and one thing that I want to show you, after all these layers of calculation, we just like join all the information that we have. While serving, we are doing a weighted combination of different ranking algorithms that we have. It seems like from the article, YouTube is using different, very much different number of ranking, and they are testing different ranking algorithms against with A/B testing, etc. And they are doing a weighted combination of the results coming from different rankers. Actually, there is no any like that. It's not like a single ranking factor or ranking function giving you all the lists ranked. You just like get lots of different ranked lists, and you just like with a weighted combination of those, you just give this to user with a ranking score per each recommendation in the list. One thing that I also read in the resources, the weighted combination coming from different signals here, different rankers, can change based on geography, based on time, etc. So in the different times, when you run all these with the same features and the same user and context features, you can get different ranking results from YouTube. There are lots of very complex computation behind that. But one important thing that I want to show from this picture to you is you got a ranking score, and you feed this ranking score, this list, to training again. You have to do this because when you do this, you are giving this information to the system. I recommended these videos in this order to that user against that video that they clicked, and they have taken these actions. To have the complete picture, we also feed back our recommendations to the training model, and we retrain our model. Continuously, we increase the accuracy of our model by feeding back to our model these ranking scores and the user engagement and satisfaction data that we store. So the training continuously improves itself. So how training continuously improves itself? This is Lambda architecture. I don't want to go very deep into this, but the idea is mostly if you have a continuously streaming data which is affecting your model, which updates your model in real time, getting this data and updating model for not convenient for all machine learning models. So what we are doing, we have two different streams. This was better. Let me show this one. Databricks. There's a better picture here. So any data, incoming data, is feeding a batch layer and a speed layer. This is the Lambda architecture. So the batch layer is buffering this data for some time and regenerate the machine learning model occasionally, like 3 times a day, let's say, and using serving layer. But also speed layer is getting the same data and creating very fast but very short time period kind of machine learning models to be used by queries. And the queries are combining batch view and the real-time view of data so that the historical data, the bulk and big data is computed in batch layer, like 2 times a day, every 12 hours, let's say. And the last 12 hours is affecting only the speed layer, and speed layer only knows the last 12 hours, and it gives some recommendation from this speed layer. That is how systems are able to recommend like last 5-10 minutes videos, very viral videos in real time near real time. This is how they are able to do. They are not updating for sure every minute their machine learning model data store. They're just like doing this daily, hourly, etc. But they are getting the advantage of another speed layer. You can just check the data breaks. I put all these into references, and also the Hazelcats references here in our page. You can check this to understand more how these systems are able to serve in near real time the latest changes in people and reflect them to their recommendations. I also want to talk about, in my last few minutes, the position bias. So what is position bias? When you recommend something to user, let's say for this video, it recommended me this list. And when I click, I see this list, right? I see these 10 videos on top, and I probably will click one of those. And then the friends of this video will come to the next recommendations, and probably I will click one of those. And then this goes on. There is no chance for a video in the very bottom of this list to be showed on top that way. Is the problem clear for everyone? Anyone who wants more clarification about the problem? Çok hızlı söyleyeyim. Buradaki size bunları recommend etti. Siz gidip sürekli evet, Burak'ın dediği çok doğru. Siz gidip sürekli zaten bunlardan birini seçeceksiniz. Sonra bunu seçince bunun recommend ettikleri yine bunun benzerleri olacak. Yine onu seçeceksiniz falan filan. Bu belli videolar hep böyle recommended olup zaten recommended olmaktan click kazanacaklar falan filan. We call this position bias. So in this video, it is talking about position.
Literatürde bunun ismi overfitting actually.
What?
Overfitting.
Overfitting. Okay, cool. So let me share my screen with voice. I forgot to do that. And I just want to play from this video.
But there's a problem here. So the problem here is, let's say you're on your web browser, you watch the video, and now you have a bunch of recommendations, but you only see the first 5 recommendations in your screen. You can actually scroll down and to see more recommended videos, but it's more likely that you click on the first 5 recommended videos because they appeared on the first page. That doesn't mean that the video that's been recommended on the last page, or if you scroll all the way down, the video there might be something that you are interested in, but you simply don't go that far to click on that. And the video that you select on the first page does not necessarily mean that you like that video. You click on that because it appeared in your face in the first page. So there's a bias there. And if you want to collect the data to retrain your model, it's going to introduce a big bias in your system. Like as you can see here, it's very likely that user click on the first recommended videos, but not because it's relevant, but solely because it's in the first recommendation or it's appearing in the first page. How the researchers resolve this issue? So they add another shallow tower here for removing this bias. And this is how they do. In the training phase here, when user starts clicking on the recommended videos, they check which position that video was. So they include that position of the video as an input feature, this tower here. So basically there's a position feature and maybe the device that the user is using, because it's sometimes different screen sizes can affect how users scroll up and down. So, but the main idea, the core idea is that they include the position of the recommended videos as an input during the training phase, and they got the logit and they concat it with logits coming from the big network that we saw, our main recommendation system on the engagement part. So here's the logit that they got from a shallow tower, and they concat it with the logic in the engagement objective part. And why just engagement? Because position is going to affect whether a user is going to click or not. So they include the position of the recommended video as one of the features when they want to predict the user engagement. This is in the training phase, but in the serving time, in the inference time, in production, they remove this feature. Similar things have been proposed before. For example, sometimes math is much simpler. In training time,
yeah, this was one of the solutions, and this is also mentioned in Google's article. In the past, in Vida Health, I remember we have done a very, very naive way of this. We were just like 10% of users, we were just like giving very random recommendations, not computed and calculated by any machine learning ranking. Just 10%, very random. And we were collecting the information from this 10%, and it was boosted in ML training, actually, because it was more kind of like it doesn't have any bias. And 90% of users were just like getting just computed recommendations. So we were sacrificing 10% of users. That is true. Vida Health was not a very big company and invest in data science, but like it was a good way that we are able to deal with this position bias for our recommendations. Yeah, this is today's session. I know here many people know better than I or Fatih. They are working in this area, and if we can do a follow-up and go deep dive into more like the data pipeline and machine learning aspects of this recommendation engine, maybe in the data engineering stream, we can do another session, follow-up session. But for system design, that's it. This is kind of like a very high-level system and machine learning design of a recommender system. Thank you. Any questions or comments?
Thank you, Erdem.
Okay, then I update this done. Cool. Thank you. The link of this page is shared in system design. You can just check. Ibrahim says transformer model works same way, adding position embedding to the raw data to trace position of some important features of data. Thank you as well. You're welcome. And see you in the next session. Thank you.
Thank you.
Thanks.